exercise number 4. Fourth question and fifth question of the syllabus is same. Fourth question, whatever it has given, just he has given an extension as the fifth question. The entire question, fourth question, whatever that you solve, just he has added one more thing. Size the service means cable for the exercise 4. That becomes your fifth problem. So it is not a different question. Fourth and fifth question both are same only. So by just seeing the line diagram of the fourth question, you might get or you might think that it is a very big question. No, it is very easy one. You just have to concentrate how to solve. Okay, first what he says that hostel building in a polytechnic has 3 floors. So we have to draw 3 different sub-circuits. The first and second floors are similar to ground floor, and there are 20 rooms. This sentence, the first and second floor are similar to ground floor, says that all the 3 floors are similar, and there are 20 rooms and 14 bathrooms in each floor. That is what he mentions. Each floor contains 20 rooms and 14 bathrooms. Each room is having 2 light points. So each room is having 2 light points. To overall 20 rooms, 2 light points, it becomes 40 lighting points for one floor. Then one fan point, each room will have one fan point and one 5 amp socket point. So this is what the understanding. Then each bathroom has one light point. Each bathroom is going to have one light point. So that what happens, for each rooms, 40 light points for rooms. For 20 number of rooms, we will have 40 lighting points and 20 fan points and 20 5 amp socket points, and each floor is going to have 14 bathrooms. So each bathroom will have one lighting point, so that 14 lighting points extra. Okay, now common room in each floor has 4 light points, 2 fan points and 2 number of 5 amps socket outlet. So the common room, whichever that is going to be there in each floor, okay, it is going to have 4 light points, 2 fan points and 2 number of 5 amp socket. So this is one more extra thing that is to be added in each floor. Then corridor and staircase is having 11 light points for each floor. So corridor and staircase will be having overall put together, they will have 11 light points. And one more extra thing, ground floor is going to have 8 outdoor lighting points. Ground floor is going to have 8 outdoor lighting points. So that is what we have to mention. Then design an electrical network for the hostel building indicating the ratings of the each protection devices used as the mains and the switchboard level. So we have to design this circuit and give the list of materials is what important. So let us go to EcoDial Advanced Calculation software. So in this software, okay, as I zoom out, you people can see how big this solution is going to be, but it's very, very simple. As I keep on explaining, you can just understand. We are going to select a HV source, high voltage source. Okay, this is how we use this high voltage source, where you can get, if you have a doubt where I will get this source at, this is what your source, HV source. Okay, so or MV source you can use, MV, medium voltage source. So then we go to once you put this MV source, just go to distribution, select the bus bar, just place this bus bar. Once you place this bus bar, okay, you need to just drag it. I have already shown in my previous videos how to drag the bus bar so that it extends for your need. Then once you drag your bus bar, then we are just going to add three more feeders. As you can observe in the diagram, we are going to add 1, 2 and 3 feeders. So let me just zoom in and show you. We have used any normal feeder and I have just extended for the purpose of making some space for the further circuit. So then I do add one more bus bar. Okay, feeders will be available, like you have some feeder sections over here, feeder circuit. So whichever you want, you can just select and put it over there. That is not a big deal. Then coming down to the further part, again I'll be using this bus bar. So once I place this bus bar over here, once I place the bus bar over here, even I'll be extending that bus bar. Once we extend that bus bar, next we are going to add loads. Okay, just coming down and observing. So this is solutions. I just want to check the data and calculation results. Okay, let me go down to data. So here you can observe. So we have used this is a socket load. Okay, when we go to load, we have cable and socket load, we have cable and lighting load, we have cable and motor load. For fans we can use cable and passive load, or even we can use cable and motor load, but because your fan works with a motor, but so most generally we'll be using the cable with passive load. That's it. Okay, we'll just mention the wattage, whatever that is being required. So for each socket load we have considered 0.06 kilowatts, the kilowatts of load. Okay, and what we have done here, we have not drawn 20 different socket loads for the 20 different rooms. What we have done, we have just mentioned, okay, we have just mentioned the number of loads into 20, number of circuits is to 20. Okay, where to convert it into 20? Here we have number of circuits is equal to 20, that is been mentioned here. So 20 number of circuits is assumed by the software itself. So next what happens here, we do have something called as kilowatts. That is what we are going to mention here, as I already told in my previous videos, and this is how it is going to occur. And then if you have single phase network, you need to mention single phase network. If you have two phase is most generally not available. Three phase or three phase and neutral, you can mention. Single phase and neutral is what we have in the problem. That is what we are going to mention. Then coming down to the next load, that is lighting load. So yeah, this is your lighting load. So how you are going to mention this lighting load? You observe, just and coming down to, this is the special room load. Okay, so what we have done here, so 20 number of circuits is equal to this is the load for 20 rooms, whatever that they are going to have, all this been mentioned here in this part of the circuit. So 20 rooms is going to have 20 number of lamps, that is what mentioned here. Okay, this is what mentioned here. 20 rooms are going to have 20 number of circuits, and 20 number of lighting points, and 20 number of lighting points again, one more, and the maximum limit, whatever that we can number as number of circuits, is 20. So that is why for 40 number of lamps we are going to use 20 number of lamp loads over here. That is the criteria. Then what we do, we have sockets. Sockets also will be required only one per the one. Fans will be required only one for the room. That is why we have used one fan load for room. Totally it becomes, as we have 20 rooms, it becomes 20 number of circuits. So then coming down to, this is the socket load. You can add the socket load over here, or even you can just shift this socket load to the room, because each room is going to have one socket row. So that is why you can add the socket load in the feeder below, or even in the feeder above. That is not going to be a big difference. If at all, if you want, you can just shift it. Then coming down to the next circuit, here he mentions about the lighting load regarding the bathrooms. Okay, 14 bathrooms we used to have. Each bathroom is going to have one lamp load, so that is what mentioned here. Number of circuits is equal to 14. Then coming down to the next load in the floor. So what is the next node that we have added? This is for the special room. Each special room used to have 4 lamps. Okay, and each special room used to have 2 fan loads. That is what mentioned over. The fan load we have mentioned it as a passive load. Okay, so then each special room used to have 2 number of sockets. That is what mentioned here as 2 number of circuits. Okay, and wattage is being mentioned as shown in the calculation, or as shown in the box. 0.08 kilowatts has been mentioned for fan load. 0. Okay, 60 watts can be mentioned for lamp load, and even 60 watts has been mentioned for your socket load. 100 watts you can mention, that is not a problem. Whatever the load you want to decide, you can decide for each sockets and all. So that is not a constraint here, but it should be mentioned properly in the proper place. So then coming down to the next problem, the next circuit, that is 11 lamp load was required for each floor in the corridor and staircase. Then total number of eight number of circuits is been added, 8 number of lamps is been added, as it is a ground floor. It is clearly mentioned in the question. If you can observe, it is clearly mentioned in the question. Ground floor has 8 outdoor lighting points that is to be mentioned. So that is why 8 number of circuits of the lamp load is been added for the ground floor, but this is not added for the other floors. Everything else is going to be same. Once you draw this ground floor, you just copy the entire part and paste it over here, and the only thing that you are in need to remove is the ground 8 outdoor lighting points. Just if you remove that, everything else, the room load, socket load, bathroom load, bathroom lighting load, and even your other loads, whatever that we mentioned for the special rooms and for the corridor and staircase, every other load is going to be same. Once you put all the loads and energize, your circuit is going to turn into black. Once your circuit is going to turn into black, then you can do the calculation. Once you do the calculation, you will get the list of materials. That is what required for the examination. Once you show that list of materials, either by writing or by giving a printout, that is the final answer for the given problem. So I'll tell you one more thing. You might be feeling that we have 3 floors, sir, you have shown only 2 floors. So all the other floors are similar as it is been mentioned in the problem itself. So the once we draw the ground floor, we can just copy the entire ground floor and paste it twice. This becomes the first floor and second floor. The only load that you have to remove from the first floor and second floor is that your this lamp load of 8 numbers. That is what you have to remove from the ground floor when you copy it and mention it as a first floor and second floor. So you can just mention these names of the first floor and second floor over here. So the feeder circuit number 3, you can just go there and you can mention it as a ground floor, GROUND So this becomes ground floor now. So next if we go to another feeder, which let us just go to another feeder. Let us rename the another feeder. That becomes your first floor, FIRST FLOOR, floor, first floor. Then again I zoom out. Okay, let me zoom in once again. So let us consider this as a second floor. Okay, so this is how we can mention the changes in the program. And then this is what very easy one. Okay, the fifth problem is nothing but once you do all this, okay, once you complete all the problem, you just have to mention the cable size that is used, for the installation, okay, for the installation of the entire line diagram. So that cable size, if you find out, that is the answer for the fifth problem. This is what you are going to write down. So this is your solutions. Okay, so calculation results is what that is going to help you people. And here you cannot get the exact cable size, you just have to go here. Yeah. Okay, so let me go to solutions. Calculated results is going to give you the size of the cable. Whatever the details available here, just write down. So that is what the standard calculated results that you are going to get. Once you complete all this line diagram, just the thing that you have to do is go to calculation project and calculate the results. Once you click on the calculate the project, the project calculation has not been updated. It is going to mention over here. When it shows like this, you just have to click on the calculate project. So that gives you the calculation of the entire project. So once it gives you the calculation of the entire project, you can get the details, like as I told you, the cable size, length, and every details that are being mentioned in the calculation results. And once you get those details are important for putting up it into the paper in your examination. Okay. Let me just complete this calculation of the network. Once it completes, I'll just show you the updated results, and I just wind up this video. Okay, so calculation of the project has been updated, so that is why it is not mentioning anything over here. And then just we have to zoom in, and this is what the updated results and all. So calculation results, these are every single feeder, every single load will be updated with the given details, and this is what it is going to be, and this is how you need to get the details. And once you get the details, just you have to enter all these details into your booklet, and that is what the answer for the given question. And even you can export the details of the solution table, whatever the circuit breakers whatsoever you people do have, that you can copy, you can extend it. So here where you can export from. Okay, once you click on the export, it will ask you how many tabs are to be exported, only the selected tab or all the tabs. Just click on all the tabs, and whatever the details that are asked by your examiner, you can just put it in front of him. Thank you.